Okay, hello everybody, this is Dr. Muhammad Badain. I'm going to be teaching you today how to solve for this integral. So the integral is 1 over 3 plus the tangent of x dx. So there are many ways actually to solve for this integral, but one of the easiest ways to solve for this integral is to rewrite the tangent of x as sine over cosine, and then we can go ahead and multiply the numerator and the denominator by a cosine. So that's what we're going to do here. So I'll call the integral we're going to call the integral I, and that is going to be equal to the integral of, we need to multiply the numerator by a cosine, so that would give us a cosine x in the numerator, and 3 cosine x plus sine x dx in the denominator, okay? And then we can force the numerator to be exactly the same as the denominator, and to do that we need to first multiply the numerator by 3 cosine x, and then we need to add up sine x and subtract sine x, okay? And of course, because we have multiplied the cosine by 3, so we need to divide everything by 3, okay? And then the same exact denominator, 3 cosine x plus sine x, and we can make this longer, dx, don't forget the dx. Okay, so now if you can notice, guys, this is exactly like this one here, so they would cancel out, and that would give us 1/3. Okay, so now we can distribute the 1/3, so 1/3 the integral of dx, which is the first part, minus 1/3 the integral of sine x over 3 cosine x plus sine x dx. And then we can force the numerator in the second integral to be the derivative of the denominator. So we can notice that the derivative of the denominator is minus 3 sine x plus cosine x. So we have sine x in the numerator, so we need to multiply the numerator by minus 3, and also we need to divide by minus 3 so that the whole quantity does not change, and we need to add up sine x and subtract sine x, of course, so that the quantity does not change as well. So that's what we're going to do. The first integral would, of course, give us x divided by 3, so we're done with the first integral. And then we need to, as I said, multiply by minus 3 and divide by minus 3, so that would give us plus 1/9 the integral of minus 3 sine x plus cosine x, and we need to subtract cosine x, of course, over the same exact denominator, which is 3 cosine x plus sine x, and then dx here. Okay, now you can notice, guys, that this part here is the derivative of the denominator, so we can split the numerator over the denominator. So the first part would give us the natural logarithm of the absolute value of the denominator, right? So that would give us x by 3 plus 1/9 the natural logarithm of the absolute value of the denominator, which is 3 cosine x plus sine x, and then what is left is going to be minus 1/9 after distributing the 1/9, okay, over the integral of cosine x over the same exact denominator, which is 3 cosine x plus sine x dx. Now if you can notice, guys, this integral here, the last integral that we ended with, is exactly the same as the integral that we started with. So basically this whole thing here is equal to I. So basically we can delete all that, and we just need to subtract 1/9 of I, and I can take that out, okay? And then the other thing that we do, we need to move this to the other side here. So that's what we're gonna do here, okay? We have I on the left hand side, and 1/9 minus 1/9 on the right hand side. So if you move that to the other hand side, we're gonna get 9/9 plus 1/9, so that's gonna give us 10/9. So I would end up equal 9 by 10 multiplied by the whole thing, which is x divided by 3 plus 1/9 the natural logarithm of, the natural logarithm of the absolute value of the, the natural logarithm, forget the natural, ln, the natural logarithm of 3 cosine x plus sine x, and then we need to close the brackets, plus c. And then we need to distribute the 9/10. Okay, so that would give us 3 by 10, right? 3, because 9 divided by 3, that's 3 over 10x, plus 1/10 of the natural logarithm of 3 cosine x plus sine x and plus c, and that's the final answer. If you like this video, hit like, subscribe to my channel, and follow me here. See you in another video. Thank you.